Look at what this question on the board here. If you are going to write UNIPORT Post-UTME, right, you want to pay close attention to this video. Now, not only UNIPORT Post-UTME, only every other Post-UTME exam you'll be writing, right? And if you are writing what physics, electric field is one big aspect of physics that you must always see in your exam. So I will use this thing to explain one of the vital law in physics, what it calls what Ohm's law, right? I will use to explain there. I want to solve this thing for you, so you want to pay close attention. I've done a complete video on electric field, right? Now that video is only available to my private one-on-one students. So if you're interested to score there, I prepare very effective, prepare very well for the upcoming post-UTME exam, then you need to join my private one-on-one class. So I'm going to take you one-on-one. I'm going to tell you more about the class later. But now let's look at this one here. Now the law we are going to use here to calculate is called Ohm's law. Ohm's law. And I believe every student should be able. So I believe every student should be able to know what's called Ohm's law, right? Now, what is Ohm's law? Ohm's law states that the current passed through a metallic conductor is directly proportional to the potential difference, provided temperature and every other physical condition of the metallic conductor are kept constant. So that is V is directly proportional to I. It's okay. You should be familiar with this one here. D is directly proportional to I, right? Of course, we want to remove what sign of what proportionality here. We want to introduce a constant. And the constant here is going to be what R, which is called resistance or resistor, right? So now going to be V equals to what I what R. Now, if you look at the question very well, you see that what calculate the sum of currents, right? I1 and I2. So you need to calculate what I1 that is flowing here and I2 that is flowing here. They both have common what voltage, right? So that if you want to make I submit a formula here, because that's what we want to solve here. To make I the formula here, we have I equals to what V over what R. So this is the one you are using. Just now, since you are using this one here, therefore, what I want to do here is to calculate what my I2 first. I think I2 is very easy for me to solve, right? Because if you look at it very well, my voltage V is equals to what 12 volts, right? Now this one here is having a resistor of 10 ohms, right? So the resistor here, which is R here is 10 ohms, right? Is only one resistor right here. So I can really get what my I2, right? Applying this formula here. Hope you understand. So yeah, my I2 is connected to one resistor. This voltage is what is here. This voltage is flowing, is affecting here, is also affecting here. Do you understand? Now, so my I2 here will be very easy for me to calculate equals to what? Which is what? 12 volts over what? 10 ohms. You're going to be what? 1.2 watts amperes. Remember, the unit of current is what is amperes, right? Very important. Now, since we are going to what our I2, now let's get our I1. If you look at I1 here, I1 is connected to two resistors, right? And the two resistors are connected in series. Remember, we have what called parallel connection and series connection of resistors, right? So we have different formulas to solve it here. Now, when it comes to series connection here, when it comes to what series connection of what resistors, right? Your equivalent resistor here, that is the total resistor equals to what R1 plus what R2 plus what R3 is okay. That is called series connection. Just as so, when resistors are connected in series here, the equivalent resistor is when you sum the two of them, right? So there, for I2, let me just put that for what. Remember, my I2 is what 1.2, right? So there, let me do for my I1. Remember, my voltage here is also the same thing. My voltage is equal to what 12 volts, right? How do I get what my resistor now? My two resistor here. My two resistor is going to be 5 plus 10, right? So my resistor here is going to be what 5 plus 10, which is going to be what 15. So my resistor here, our here, so what? 5 plus 10, which is going to be what? 15 watts. Do you understand? So from here now, I can now apply this formula here, right? You go to go I1 equals to my I1 equals to what? My V. What is my V? My V is what? 12 volts over. What my resistor? My resistor is 15, right? 15 ohms equals to. So let's use our calculator to get our answer here. So we have 12 divided by what? 15. Here we have what? 0.8. So we have what? 0.8 watts amperes, right? So from here, we can calculate what is total watt current, right? Total watt current, total current. If you calculate total current, what are you going to get? Calculate total current, you're going to be what? I1 plus what? I2, right? What are you going to get? Going to be what? I1 is what? 0.8 amperes plus what? 1.2. 1.2 amperes, right? If you look at it, everything is going to be total to be 2.0 watts amperes. It's okay. So you know what? Taking note of all this, they are very important. Now, these are the type of question I'll be teaching you in what my private one-on-one class. Just if you come across this video and you pay for JAM, you can also join my private one-on-one class. So I will take you math, chemistry, and physics. It's going to be an intensive class. If I should take you one-on-one class here, there's no way you not score high either Post-UTME or JAM examination. It's very important you join my private one-on-one class, right? Another thing is that if you apply for UNIPORT Post-UTME exam, you need the what? You need the legit pass question. And now the legit pass question, if you want to get the legit pass question, the link to get the legit pass question will be in the description below. Go get it. Do you understand? And if you want to join my private one-on-one class, send me a message on WhatsApp. They will tell you price, will give you price, they will start learning immediately. Thanks for watching. See you in my next video.